Hello dear students. So in the last 3 classes we have started the units and measurements. So in units and measurement we have seen the physical quantities and units of physical quantities, and in the last class we have discussed what are the SI units and what are the units of the measurement of length. Okay, we have discussed the measurement of length. Fine. So in this class let us start the dimension. Okay, so in measurement of length we did only measurement of length. Fine. So we want to do measurement of mass and measurement of time also. So we will discuss that in later. Okay, now we concentrate on the let us discuss the dimensions. Okay, so who are watching the videos, so first year science students, so please comment your name in the comment box. So then only I will come to know who are watching the videos or who are writing the notes. That will make easy to me to interact with you people. Okay, so you want to comment your name in the comment box. Fine. So let's come to the syllabus. Right? So dimension. So by listening the word dimension, so you already know that a 3D movie, 4D movie. So like that you have already know. So okay, 1D movie means there is only one direction, one direction. 2D movie means two direction. So this is two direction. So this direction, this direction. 3D means three directions. Okay. See they are mutually perpendicular. 4D means that is the space. Fine. 4D. So we are discussing that thing. We already know that about the dimension. So in physics, the dimensions also comes with its own properties and own nature. So let's discuss it. Right? The power of base. Base means fundamental quantity. Base means fundamental quantity. Fundamental quantity. The power of base that enters into the expression of a physical quantity is called the dimension of the quantity in that base. In that base. So concentrate here again. I will repeat it. The power of base. Power of base means the power of the fundamental units. The power of the fundamental quantities that enters into the expression. So expression means if we are expressing the derived quantity, then there are so many fundamental or base quantities will exist. Okay. So the expression of a physical quantity that enters into the expression of the physical quantity is called as the dimension of that quantity in that base. It means that, so dimensions, first see that the dimension of the length means the dimension of the length is denoted as L. So this is L. So you want to write the dimensions. If it comes to the dimensions, you must and should write it in a square bracket. Right? You must and should write in a square bracket. So this square bracket. Okay? So the dimension of length is L. Denoted as capital L. So dimension of the mass denoted as capital M. Fine? Capital M. So the dimension of the time is, so that's what is it must be capital T. Right? Capital T. So the dimension of the temperature is Kelvin. Temperature is denoted as its SI capital K. Right? So the dimension of the current and here current is denoted as capital A. Fine. So we are dealing with these 5 dimensional quantities in the further classes. Okay. So because these 5 are the most important, which involves in the most of the physical quantities derivations and the most of the expressions of the physical quantities. So we are dealing with these 5. So listen here. The length dimension is given as capital L and mass dimension is given as capital M. Time dimension is capital T. Kelvin temperature dimension is given as capital K, and current dimension is given as capital E. So let's see. To make it clear, consider the example for force. Physical quantity. Force is a physical quantity, right? It is derived quantity, but it is also before that it is physical quantity. So force is given as mass into acceleration. Force is given as mass into acceleration. So mass, you write mass as it is. So acceleration means velocity into time. Fine. So means length by time square, right? Length by time square. Meter per second, the acceleration unit is meter per second. Okay, meter per second square. Fine. So mass. So here is a mass. Length as it is. Time, if it comes out, time to the power minus 2, right? So we already have the dimension of the mass, right? So write it there, m. What is the length? And length is given as length means L, right? Length means L. First you have to write it again this one, okay? Then L. Then time minus 2. Here time minus 2 means t to the power minus 2 completely square root. Okay. So this is the dimension of the physical quantity, right? Dimension of the physical quantity force. Dimension formula of the physical quantity force. Why? So listen here once again. The power of the base means these are the bases. Mass, length, time are the bases. They are fundamental quantities. The power of the base that enters into the expression of a physical quantity. That enters into the expression of the physical quantity. That enters the expression of the physical quantity. Force. We are expressing the physical quantity force that enters into the expression of the physical quantity is called the dimension of the quantity. Is called the dimension of the quantity. Here we are considered force, so it is called the dimension of the physical quantity force in that base. Base means this one. Okay, is it clear? I think you understood this one. So let's move to the next concept. Okay, dimensional equation. Okay, dimensional equation. So we have studied what is the dimension. So how we give the dimension, right? So now we want to go through the dimensional equation. So dimensional equation means, let's see the definition. So whenever dimension of a physical quantity, here PQ means physical quantity, I have written in short. Okay, the dimension of a physical quantity is equated with its dimensional formula, we get dimensional equation. So let's see here. What is this? Whenever the dimension of a physical quantity is equated with its dimensional formula, it is called as dimensional equation, right? So see, what is the dimensional equation of the force? So if you ask to write the dimensional equation of the force, you must have should write this one, right? This is the dimensional equation of the force. In bracket, force F capital F is equal to M L T to the power minus 2 square bracket completed. This is the dimensional formula of force, right? So here we have equated the dimensions of a physical quantity is equated. This is the dimension of a physical quantity is equated with the dimensional formula. This is called as dimensional formula. This is dimensional formula. This one is in the square bracket is called as dimensional formula. Okay. So clear? Dimensional equation means whenever the dimensions of a physical quantity is equated with the dimensional formula is called as dimensional equation. Oh, I think it is understood by you. So now let's move to the principle of homogeneity of dimensions. So wait here. Before going to discuss this one, so let's have the view on homogeneity. Homo means same. Homo means same. Homogeneity means all the same. Homogeneity means this is a property. Geneity means property. Okay, so the homogeneity of dimensions, the principle of homogeneity of dimensions, it states that the dimensions of all the terms in a physical expression should be same. Okay, so listen here, the dimensions of all the terms in a physical expression should be same. Let us consider P plus Q minus R is a dimensional expression or physical expression. Consider this as a physical expression. This is equal to 0. Is equal to 0. Okay, this is 0. But P plus Q minus R, it is a physical expression. So it is equal to 0. This is the equation, physical equation. So what the principle of homogeneity gives? The dimensions of all the terms. So here P, Q, R are the terms of this physical expression. Fine. Terms of this physical expression. So we are doing the physical expression should be same. The dimensions of all the terms in the physical expression should be same. Okay. So see. So now the dimension of P, Q and R all same. So dimension means unit. Okay. So if P unit is length, means meter per second or length, consider meter per second, then if you ask what is the unit of Q and R, this is also meter per second only, because always the like quantities adds. Okay, always the like quantities only adds. So x plus x equal to 2x, x plus y equal to not 2x or 2y. So this is similar, but numbers don't have the dimensions. Keep it in mind. It is a key point. Right? It is a key point. So numbers or numerical values don't have the units, but other dimensions don't have the dimensions. Okay, so is it clear? So for example, we have taken the example for this one. So consider this one now. Okay, fine. Next, V equal to U plus. So V equal to U plus 80. This is the velocity equation we are going to use. So listen here. So the dimension of V is meter per second, right? Meter per second, and U is also meter per second. Then complete 80 is also meter per second, because acceleration, where A is the acceleration is meter per second square. So acceleration is meter per second square. T is second, so it implies meter per second. So this one has cancelled, here one has to remain. So again it will become meter per second. Always like quantity only adds. So principle of homogeneity of dimensions say the same one. So this is we are already using, but this equation or this principle we are now using in the dimensions. That's it. Okay. So that's dimensions. So what is that? The dimensions of all the terms in the physical expression should be same. Is it clear? I think it is clear. Fine. So the next we will move to the uses or applications of a dimensional analysis. What is that? Uses and applications of dimensional analysis. So we have dealt already about what is dimensions and dimensional equations. So there is a uses or applications in physics of this dimensional equations. So listen here, these principles or the applications of the dimensional analysis is a very important topic to be remembered throughout your first PUC and second PUC and afterwards also, because this is very important one. Very important, because in if you are going to write in any exams, any entrance exams or KSET exam or JEE, these applications are going to be very helpful for you people. Okay, very helpful for you people. So please pay attention here. Okay, to convert, so that let's see the first application of dimensional analysis. What is that? To convert units of a physical quantity from one system of units to another. What is that? We'll repeat once again. So listen it. To convert units of a physical quantity. Units of a physical quantity. Physical quantity means it may be length, mass, force, Young's modulus, anything it may be. Work done. To convert units of a physical quantity from one system of units. From one system of units to another system of unit. That means we already seen that there are 4 systems of units. What are those? CGS, FPS, and MKS and SI unit. Fine, and SI unit. So to convert the dimensions of the or the units of the one system to units of the other system. Okay, we already seen that their units are different. In CGS system, the length is measured as centimeter, mass is measured as gram, and time is measured as second. So in SI system, the length is measured as meter, and mass is measured as kg, and time is measured as second. Fine. So there are the difference. So there is the difference in value. Not all the units of the other system of units must be equal. So let's see this my example. Okay, let's convert force. One force or 1 Newton is equal to how many dyne? How many dyne? Dyne is CGS. This is SI. Okay. 1 dyne is equal to 1 Newton is equal to how many dynes? So dyne is the CG unit of the force in CGS system. Is it clear? Dyne is the unit of force in CGS system. Okay, in CGS system. Let's see how to convert this one. So let's now 1 Newton is nothing but what is the dimension formula of Newton force? That is nothing but mass into acceleration. Mass means kg. First we write mass into acceleration to understand it. Mass into acceleration. So what is mass? Mass into acceleration means meter means length. Length by time square, right? So now write it there. So write here mass in kg, length is meter, and time is second square. See, 1 Newton, right? Okay. Now see about, let's see. So we got this one. It gives some space and time. Let's verify if we have a key. Start. So 1 Newton is equal to kg meter centimeter square. Right? So 1 dyne is equal to gram, centimeter, and second square. In CGS system, length is measured as centimeter, mass is measured as gram, time is measured as second, right? So we need mass, gram, and length centimeter, time is same in all the system of units. So we need 1 Newton equal to how many dynes? So divide this one by that one. So 1 Newton is equal to how many dynes? So write this one. Kg meter second. So gram centimeter. So may similar quantity is the same thing. Grams, right? then meter by centimeter, 1, then S called as 2. So next step is, we have to remove the extra prefixes out of the bracket, right? So kg means 10 to the power 3. So first we bracket 10 to the power 3 gram. This is 1. So 1 right? And next 10 to the power minus 2 meters. Also 1 or nothing. Maybe it's okay. If you don't write, then it will be 1. Okay. Now take out of the numbers from the bracket. 10 to the power 3, 10 to the power minus 2. So just cancels meter. First we write gram by gram, meter by meter. Yes, minus 2 is cancel. So it remains 1 Newton by 1 time is equal to, if 10 to the power minus 2 comes above, it becomes 10 to the power minus plus 2 into 10 to the power 2. If it comes above, it becomes plus 1. So is equal to 10 to the power 5 plus 1 Newton is equal to 10 to the power 5 times. 10 to the power 5 times. So you may ask for the conversion of the Newton into time. So this is how we do it. Okay. So similarly we can do for we can convert force joule, and what is the calories. So we can convert all that things in one system of unit to other system of units also, and length also, and also mass, and we can time is similar in all the system of units. So no need to worry about time, and we can convert other all physical quantities from one system of units to another system of units by using the first applications of the dimensional analysis. Dimensional analysis is what is the dimensions, applications of the dimension. Application of the dimension concept. That's it. Okay. Is it clear? I think the first application is clear. So we'll go to next application of the dimensional analysis. There are totally 3 applications of the dimensional analysis.